Today is covering a few sections here: implicit differentiations, related traits, and the last one is the mean value theorem. And then start with the next chapter, the beginning. Okay, so this is implicit differentiations. Okay. Turn off my video. Right, first about implicit differentiations. Okay. About implicit differentiations. Okay, if we write something like this in sometimes why we write something like this, all right, so it means technically x is the what we call the free variables and y is the bound variable. So in this term we say that y is expressed in term of, so we say y is as a function of x, variable x. Okay. So this kind of thing we say explicit. Okay. When we write something like this, f x squared sine cube plus x plus 7, something like this. This is explicit. Now, if I refer something about explicit, then there must be something in the opposite of explicit, which is implicit. So what is implicit? Okay. All right. Then we have a graph of functions. So this is graph of functions. In graph of functions, you have a vertical line test. What is vertical line test? Okay. What is the vertical line test? This is every x, y, every vertical line intersect the graph at most once. Okay, so if you take something like this, all right, so it intersects there only once. And if you're going something outside the domain, you are not intersecting the graph at all. Okay, so this is a graph of functions. So it explains why a circle is not a function. And something like this. Okay. So this graph is not a functions. Okay. Yes, this is not a functions. Why? Because here, if you take this one, for example, you get two intersections. Even though if you cross it here, you don't have any intersections. But if you cross it here, you have two intersections. Two intersections. For this particular x, say x naught, you have y1 and y2 corresponding. Right? It's not not the functions. Okay. So what we say implicit is that, well, this is a something that we call a graph, a function of two variables. So it's f, x, y. This is function of two variables. Okay. So in this case would be okay. So this graph is a function of two variables. So it is f x y equals 1, but two variables. Okay. And so this expression is called implicit. What is implicit of what relative to what? Okay, so this is implicit. Sometimes we say that y is implicitly function of x, or the other. On the other hand, we can say also is. So in this case, we would call something like this. Or on the other hand, you can have also x in terms of y. Okay. And if you try to make it implicit, sorry, and make it explicit. Y is function of x, or x a function of y. Okay. So in this case, that means you're trying to solve the if you solve it for y, okay, you get something like you there. But remember that you don't have only one functions, but two functions. It means you have y plus and y minus. You have two expressions. This is explicit. y as a function of x. And similarly, you have also x as a function of y. Sorry. X plus y squared, or there. Okay, so you see, this is the difference between explicit and or implicit. And you can try to change implicit to explicit, or on the other hand, you can change also. All right. So the thing is, if you have explicit expressions can be transformed into implicit. That's easy because explicit. So to make it implicit, you just move there. This one is implicit. So for example, if you have a, that's easy part, okay? So we change this to y minus x squared equal to 0. That's implicit. On the other hand, if you try to change implicit from to explicit, okay, sometimes it's easy, sometimes doable. For example, that thing becomes y, although you have two expression now. You don't have only one expression, but two expressions. But sometimes it's just outright impossible. So often impossible, or at least difficult. So for example, let's make some complicated one. I think we're good at making things complicated. Uh, okay, this is implicit. But is it possible to make the expression explicit? Well, I don't know, but I guess it would be difficult. It's not impossible. Y equals something in terms of x. Okay. Okay, so that's about what is explicit versus a implicit. Okay. All right, so let's do calculus on this implicit explicit thing. Now the question is now about this. Now you're given a circle, unit circle, x squared plus y squared equals 1. And the question is find the equations for tangent line at the point. All right, so let's see the graph first. Okay, so this is 1, negative 1, negative 1, 1. All right, so what we trying to find is this in the center here. Okay, so this is 45 degrees. This is 45 degrees, then this point has a coordinate to at this point. Okay, so just by symmetry, because this is symmetric, so you would guess that slope 1. Yes, by symmetry, the slope must be 1. Okay, so using these informations, the tangent line is, let me see, y subtract this 1/2 square root of 2, slope is 1, x minus square root of 2. Okay, that's how you get this without calculus. Just recall this is a symmetric. At any other point, that would be difficult because we need to find to compute the slope, which we need calculus for that. Okay. All right. So if we want to do calculus on this thing, say this is the point. First thing is find slope. Slope is at point this. Okay. Now the question is, what is f? Okay. So x0, that's easy. X0 here is this one, x0. But what is f? Because we don't have f here in implicit thing. So this is implicit. Okay. This is implicit. So what we do here is that f comes from making explicit expressions. Y is a function of x. Okay. And we can do this because y is, it can be plus or minus. Okay, so depending on the which part of the graph. Okay, so on the top, above the x-axis, you have the y plus. Below the x-axis, you have the y min. Okay, so basically this is you have two functions. Okay, so this is explicit. Okay, so because the point we need is in above the x-axis, so what we need is the f plus. x naught y naught is above x-axis. Okay, so what we have here is that okay, so slope is x, right? So let's compute this one. All right, how to compute this one? Well, use the, remember, chain rule. Okay, so this one as a, using chain rule, so remember that the, if you have square root of x, remember that the chain rule, this is 1 over 2 square root of x. Okay, so what we have here is that this is our g. This is the outside. This is the inside functions. Square root is the outside function. Okay. So what we compute is now, what we get is 1 over 2, because this is derivative of the outside functions computed at the functions inside. So that's what we have. Okay. But then you have to multiply by a derivative of what's inside. So inside you have 1 minus x squared. So you have derivative minus 2x. So cancel the 2. So you have oh, sorry. I forgot the sign here. You see that this is decreasing, so it cannot be 1. Right? So what it should be?
-1.
Minus 1. All right, good. So, minus 1. Okay. So let's compute this one. Okay. So at x all equals 1, just plug in this one. Minus square root of 2. This is square root of, this is square becomes 1/2. Okay, so finally you get, this is another one, square root of 1/2. This is square root of 1/2. So you get, right? Okay, but in you see that same same steps that we need. Equals for tangent line. So y minus this m. Okay. All right. We can do this. Uh, this is just in unfortunate situations that you can compute f. So we can find the explicit expression. And the thing here with these functions, which one? Something that we make it difficult here. There, for example. In general, this is a graph of a, say, just a graph. Okay. So if it is a graph, then it makes sense to find a tangent line. Okay. So, but in finding a tangent line, you need the functions explicitly. So how we should do this if we cannot find the explicit expressions. Okay, so this is what I would like to find. Slope as a derivative expressions of the functions. Yeah. So this is the thing that make things difficult. So just pick a problem. Let me find a problem first. Okay. Okay. Let's see. Example, this one here. Agent. Line of the graph. This graph here for x squared y minus 3y x cubed over 1. Okay. At the point say if x 0, then y should be let's make it something easy. 4 minus 3. Which point satisfy these equations? So if x equals 1, for example, it should give y. This is 4y minus 3y, so y equals 0. That's easy. Okay, so you can plug in 1 0 here, and this that will satisfy the equations. So plug in 1 to x, so this minus 4y. Let's see. 3y, okay, equals this one. This is y equals 0. All right, so it is at point at the graph. So okay, make sure this point is at the graph. On the graph. Okay. All right. So this example, it's still easy to solve. Okay. If you solve this, that's easy. This is how to solve this one. You can factor out the y. Okay. And you have this. So you still can solve this one. Okay. And you still can find the slope. You have x equals 1. Okay, so then this is what we call implicit differentiations. Okay, so in implicit differentiations, this is what you do. Okay, so let's define functions, I would prefer using capital F here, two variables. So let's put in one y. So let's put this x cubed minus 1 to the left, move it here. So, okay. So this expression becomes uh, a functions. This says that f(x) of y equals 0. Okay. All right. So let's take derivative. So we assume y is a function of x. Why we can assume this? Can we assume x as a function of y? Of course, you can do that. Okay, but let's just assume this one. So here's x is variable, y is function. Okay, so let's take derivative with respect to x. Okay, so let's take the derivative respect to x. Now this notation becomes convenient now because it tells you take derivative with respect to x, not to y. Okay, so of course you would have later a d over dy. So take derivative with respect to x. Okay, so how do we do this one? All right, so think this about, this is a product, a multiplications. Okay, two functions. So the derivative is the product rule, derivative of 4x squared, which is 8x multiplied by y. Okay, and again, you have another term, one more term, that is 4x squared. Oh, because y is a function now. It is, the derivative is there. Okay. And this is function. Derivative of xy is x1y. This is bc, it's 0. Left-hand side 0. Okay, so you can take y prime out. Y prime out, factor this as 3. Okay, and remove the terms which does not contain terms don't contain a y prime to the right. So here you remove 3x squared and minus 8. Right. So finally you get this y prime. Okay. So this trick is called implicit differentiations. Implicit differentiations. So in implicit differentiations, you don't need the function to be explicit. Just take derivative. Okay. Are you with me?
Yes.
Questions? Right.
Not for now.
So let's go back to our problem here. Okay. So the simple questions. Find tangent line of this one. Can we do this implicitly now? Let's go back to this problem. Let's do this implicitly. Here. Circle problems implicitly. So let me just follow the graph again. We have here. Okay. So this is the x squared plus y squared. Okay. So this is implicit. So you compute pdx both sides. Okay. And what you get here is that you take derivative with respect to x, and that is 2x. Okay. And then compute derivative of 2y. But we here assume x is variable, y is function. So when you take derivative of functions, you're not only getting y, but you have, all right. What kind of rule we get this one? How do we get this 2y, y prime, instead of just 2y?
Chain rule?
Chain rule. This is chain rule exactly. So you can compute this. Y is just negative 2x divided by 2y, which is okay. And when you compute the slope at the point square root of 2, that's y prime, you compute at this point. Okay. So you plugged in the number, which is negative 1. Okay. So that's, so you get this one. So this implicit differentiations the uh, cut the problem that we had. The problem we had earlier is that writing this explicit function is not always easy. It's often difficult. But now you don't need the explicit expression anymore. Just do implicit differentiation. Okay. So that's why it's easier using implicit differentiations. Now, the drawback is that in computing y prime, you may need also y. The expression contains not only x, but also y. Okay? Because in implicit, you're assuming this is a function of x and y. Okay? So in this expression, x and y are both variables, into variables. Okay, so you have x, but y is a function of x. Okay, so let's do some more example. Let's see now. Let's do one. Actually, we do the share screen. Okay. What is the display showed at this time? Is it the textbook or the OneNote?
The textbook, sir.
Textbook. All right. So
Yeah, it's textbook.
okay. So let's do some problems. Go to the all right. So see this problem here. Let's solve this one. Just writing here. So y cubed minus xy squared plus cosine xy equals 2. Okay. So you need to find the tangent line to the curve at the point 0, 1. If you plug in x equals 0, you get y equals 1. Check that one. Plug in x equals 0. So that's this, this is 0. In 0, 1. 0. And this is 1. This is 0. This is cosine 0. Cosine 0 is 1. Okay, that's correct. Okay, so this point is on the curve, on the graph. Okay. Okay. Let's do implicit differentiations. Just do this here. Over dx, that means assume y is a function of x. Okay, so x variable, y is function. Okay, so take derivative. What is derivative of y cubed? Here, the y squared and what?
Y accent.
Y, right? Here, this is a product. So use product rule. So derivative of x is 1 times here. You have another term, x times derivative of y squared. But remember, y is a function. So you get x and y. But you have also y prime. Let's see. Derivative of, now this is complicated because you have product rule inside the cosine. So you have cosine become sine, the chain rule, okay? Negative sign. It doesn't change the angle. The angle is xy, but then you multiply by derivative of the angle. The angle is product rule. So derivative of x is 1, and x times derivative of y. There you go. And this is 0. Okay. So here now you substitute 0, 1. And you don't need to solve actually y prime. Just plug in 0, 1. Okay. Just one step to say to minimize the possibility of making errors. Okay. All right. So this is what you get with plug in 1. That's y. So this is 3 y squared and y prime. This is 1. And this is 0. Okay, x. Okay. Minus sine 0, which is 0. All right, so then make things disappear. Okay, so it turns out, let's see, the 0, 1, move this 1 to the right. -1, so become plus. So eventually we get y prime is 1/1/3. Okay, at this point. Okay, so that means what we mean by implicit differentiations. So this step is kind of redundant, so you don't need to do this one. You just get this one plugged in directly to this one. You don't need to plug in 0, 1 here, but here, this step. So that's implicit differentiations. Okay. All right. So then last one is this one before we take a break. Okay. Uh, can you see the one note again?
Yes, sir.
All right. So this what we call the power rule. Rational power. So we know the formula. If you take derivative of x to the n, this is n x to the n minus 1. That holds for n, see, just integers. Okay. But let's generalize. Let n be a rational number now. The question is, what is uh, r? R is rational number. This is questions. Okay, so let's do this one. So let y equals x to the r. R is p over q, so that's okay. And let's raise to the power of q. So if you raise to the power of q, then you have this, right? And here you just p. Okay, and then you take implicit differentiations. Because now both has a integer power. So assume x, y is a function of x. All right, so you get this one here. So q minus 1. Right? And here you have p. Oh, sorry. You got a use chain rule here. So there must be some y prime. Right hand side, that's easy. So if you solve for x, sorry, solve for y prime, you get this one here. P q times y. So what is this? P over Q. So I just write this as R. Okay. Now, okay, that's better. This is X P to the Q, and P minus 1. And then what is Y? Y is X to the P over Q. So this is X to what is this one? Okay, so X P over Q power Q minus 1. Okay, so how we compute this one, this power here? X3 P over Q power again Q minus 1. So X multiply this. Okay. Slightly complicated. All right, so how to compute this power? Okay, to compute that power means that you subtract P minus 1, subtract P. And what you get here. Okay, so that's there you go. Okay, so what do you get from here? So QP, this is PQ, right? So they cancel. So what you have here minus Q. So and this is minus P, so just plus P over Q. Okay. So what we have here. So this is P over Q minus 1. Okay, so it equals to R minus 1. All right, so if you cancel this, so it's R, this is X to the R minus 1. Okay. So this shows you that this formula is not only true for our integers, but also for our rational. Okay. So now you can easily compute if what is derivative of say x to the 4/3. That'd be easy because now it's just 4/3 x to the our formula. Okay, and if you take this y, for example, you get what's this y 1/3, but you have okay. Of course, it remains kind of mysterious. is it possible we have this? Okay, so we'll deal with this later on. Okay. Let's stop here, take a break. About 8 minutes, and we'll start at 8:10. Okay. Okay, sir. Yeah. Just stop the record.